Hello viewers, welcome to online lecture series on Fourier transforms. This is lecture number 11. Let me recall what we did in the past two videos. In lecture 9, we derived partial identities for Fourier transforms, and in lecture 10, we solved some problems on Fourier transforms and applied partial identities to evaluate certain integrals. In this lecture also, we shall continue working out some problems on Fourier transforms by applying Parseval's identities. You are all familiar with Parseval's identities now. These two are Parseval's identities for Fourier transforms, and these are Parseval's identities for Fourier sine and cosine transforms. Let me read them again. First identity is 2 by pi times integral 0 to infinity fs of s into gs of s ds is equal to integral 0 to infinity f of x into g of x dx. And the same identity also holds for Fourier cosine transform, that is second identity. In case when f of x is equal to g of x, we get 2 by pi times integral 0 to infinity fs of s whole square ds is equal to integral 0 to infinity f of x whole square dx. The same also holds for cosine transform. So these are four identities for Fourier sine and cosine transforms. Now let us solve some problems on them. Problem number 1 is, using Parseval's identity, show that integral 0 to infinity 1 by x square plus a square into x square plus b square dx is equal to pi by 2ab into a plus b. Now to evaluate this integral, we consider two functions f of x is equal to e power minus ax and g of x is equal to e power minus bx. Because one who is familiar with Fourier transforms well knows that Fourier transform of e power minus ax is a by x square plus a square, and Fourier transform of e power minus bx will be b by x square plus b square, and we need the same terms in the integral. So that is the reason we consider for f of x is equal to e power minus ax and g of x is equal to e power minus bx. Now let us derive the Fourier cosine transform of f of x, that is fc of f of x, which is equal to integral 0 to infinity f of x into cos sx dx, that is integral 0 to infinity e power minus ax into cos sx dx. And if we apply the integration formula for e power ax cos bx, we get it as e power minus ax by a square plus s square into minus a cos sx plus s sin sx within the limit 0 to infinity. Now if we substitute infinity here, e power minus infinity becomes 0. So first term becomes 0 minus. Now if we substitute 0, we get e power 0 is 1 by a square plus s square. Cos 0 is 1, so it is minus a, plus sin 0 is 0. So after substitution of limits, we remain with the term a by s square plus s square. Therefore, Fourier cosine transform of f of x is given by a by s square plus a square. Similarly, if we find Fourier cosine transform for g of x, we get gc of s is equal to b by s square plus b square. Now let us use Parseval's identity for Fourier cosine transform, which states that 2 by pi times integral 0 to infinity fc of s into gc of s ds is equal to integral 0 to infinity f of x into g of x dx. Now let us substitute all the function values here, that is fc of s is a by s square plus a square, gc of s is b by s square plus a square, and f of x is e power minus ax and g of x is e power minus bx. So after substitution of function values, we get 2 by pi times integral 0 to infinity a by s square plus a square plus into b by s square plus b square ds is equal to integral 0 to infinity e power minus ax into e power minus bx dx. Taking outside this a and b, we get 2ab by pi integral 0 to infinity 1 by s square plus a square into s square plus b square ds is equal to e power minus of a plus b into x, because e power a into e power b can be written as e power a plus b. Therefore, this is e power minus of a plus b into x dx. Therefore, this integral 2ab by pi integral 0 to infinity 1 by s square plus a square into s square plus b square ds is equal to integral of e power minus a plus b into x is e power minus a plus b into x divided by quotient of x is minus of a plus b within the limits 0 to infinity. So, if we substitute the limits, upon substituting infinity here, we get 0 because e power minus infinity is 0 minus. Now substituting 0 in place of x, we get e power 0 is 1, therefore 1 by minus of a plus b. So which is equal to minus into minus becomes plus here. So this is equal to 1 by a plus b. Therefore, now integral 1 by s square plus a square into s square plus b square ds is equal to this 2ab by pi comes this side, comes to right hand side and becomes pi by 2ab into a plus b. Now, if we just replace s with x in the above integral, we get integral 0 to infinity 1 by x square plus a square into x square plus b square dx is equal to pi by 2ab into a plus b. So, using Parseval's identity on Fourier transforms, we can evaluate such integrals. Now, let us look into another problem. Using Parseval's identity, show that integral 0 to infinity t square by t square plus 1 whole square dt is equal to pi by 4. Because we have t by t square plus 1 in this integral, we consider f of x as e power minus x, and if we derive Fourier sine transform of this f of x, we get it as s by s square plus 1. Because we have t by t square plus 1 whole square in this term, we are considering f of x is equal to e power minus x, and we find out Fourier sine transform of f of x. So, Fourier sine transform of f of x is equal to e power minus x is integral 0 to infinity e power minus x into sine sx. By applying the integration formula here, we get e power minus x by minus 1 whole square plus s square into minus sin sx minus s cos x within the limit 0 to infinity. Now substituting the limits, upper limit is infinity. So if we substitute infinity here, e power minus infinity becomes 0. So first term is 0 minus, if we substitute 0, this is 1 by s square plus 1, sin 0 is 0 and cos 0 is 1. Therefore we will have s here. So after substituting the limits, we get s by s square plus 1. Therefore, Fourier sine transform of e power minus x, which is given by s by s square plus 1. Now let us apply Parseval's identity for Fourier transform, which is given by 2 by pi times integral 0 to infinity fs of s whole square ds is equal to integral 0 to infinity f of x whole square dx. Substitute fs of s as s by s square plus 1 and f of x as e power minus x. So we get 2 by pi integral 0 to infinity s square by s square plus 1 whole square ds is equal to integral 0 to infinity e power minus x whole square is e power minus 2x. And integral of e power minus 2x is e power minus 2x by 2 within the limits 0 to infinity. So if we substitute the limits and simplify, we get the value of this integral as 1 by 2. Therefore, 2 by pi times integral 0 to infinity s square by s square plus 1 whole square ds is equal to 1 by 2. If we bring this 2 by pi to right hand side, we get integral 0 to infinity s square by s square plus 1 whole square is pi by 4. Now replacing s with t everywhere, we get integral 0 to infinity t square plus 1 whole square is equal to pi by 4. This is what the value of the integral we need in the given problem. Now let us go to another problem. Using Parseval's identity, show that integral 0 to infinity sin at by t into a square plus t square dt is equal to pi by 2 into 1 minus e power minus a square by a square. So we have here 1 by a square plus t square, a square plus t square. So that is why we take f of x is equal to e power minus ax here, and we have sin at by t here. So for that we take g of x is equals to, we define g of x as this function, because if we derive Fourier transform for this g of x, we get it as sin as by s. So on little practice we can define such functions. Now let us find Fourier cosine transform of f of x, which is already derived in problem 1 in this lecture as a by s square plus a square. Now let us derive Fourier cosine transform of g of x. Fourier cosine transform of g of x is integral 0 to infinity g of x into cos sx. Depending on the definition of g of x is defined in the interval 0 to a and a to infinity. Accordingly, we split the integral in these two cases as 0 to a and a to infinity. So substituting the corresponding values of g of x in the interval 0 to a, g of x is 1, and in the interval a to infinity g of x is 0. So after substitution, this entire term becomes 0, and the first term, this term becomes integral 0 to a cos sx dx. Integral of cos sx is sin sx by s within the limit 0 to a. So after substituting the limits, we get sin as by s, and lower limit is sin 0, that is 0. Therefore, we have sin as by s. So Fourier cosine transform of g of x is given by sin as by s. Now by using Pascal's identity for Fourier cosine transform, that is 2 by pi times integral 0 to infinity fc of s into gc of s ds is 0 to infinity f of x into g of x dx. Now let us substitute the values of fc of s, gc of s, f of x and g of x in this identity. We get 2 by pi times integral 0 to infinity a by s square plus a square, this is fc of s, into gc of s is sin as by s ds is equal to integral 0 to infinity f of x is e power minus ax and g of x dx. Now let us split the integral in the right hand side as integral 0 to a plus integral a to infinity, and substitute the corresponding values of g of x as 1 and 0. So that we get 2a by pi times integral 0 to infinity sin as by s into s square plus a square is equal to integral 0 to a e power minus ax dx. Integral of e power minus ax is e power minus ax by minus a within the limits 0 to a. On substituting the limits, we get the value as 1 minus e power minus a square by a. Therefore, we obtain integral 0 to infinity sin as by s into s square plus a square ds is equal to pi by 2a square into 1 minus e power minus a square. Now by replacing s with t, we get integral 0 to infinity sin a t by t into t square plus a square dt is pi by 2a square into 1 minus e power minus a square. So these are some problems for exercise. You can try yourself. This problem number 4 is evaluate the following using Pascal's identities. First one is integral 0 to infinity x square by x square plus a square whole square dx. And second integral is integral 0 to infinity 1 by x square plus a square whole square dx. Here are some hints for you to derive these two integrals. Follow these hints and solve the problem. And you also have another problem using Pascal's identity. Show that integral t square by t square plus 4 into t square plus 9 dt is equal to pi by 10. We have here t by t square plus 4 into t by t square plus 9. So we have s by s square plus 4 and s by s square plus 9. And we know that s by s square plus a square is Fourier sine transform of e power minus ax. So that is why we consider f of x is equal to e power minus 2x and g of x is equal to e power minus 3x, and we evaluate Fourier sine transform and then apply Pascal's identity to derive this integral. So you can easily solve them, try it and obtain the solution. So thank you for watching the video. Thank you.